Okay, some more modulation. And I guess we'll wind up with two questions out of the previous set and two out of this one. That'll actually be on the exam. And now we're going to talk about digital modes, which I've referred to, where we're going to send digital data instead of voice. We talked about packet radio. That was one of the first digital modes around, except for CW, which I consider a digital mode, but they don't normally lump it in here. You may have heard of IEEE 802.11, which is your Ethernet on Wi-Fi. 802.11 is Wi-Fi. And it's a digital mode. Probably the most popular digital mode at this point in time is FT8, which was set up to do weak signal contacts. It's very much computer assisted. Some people don't like it because they say it's not ham radio, the computer does it, and all you have to do is push a button. That's not exactly true, but it is fairly easy to do once you set it up. PSK 31, which stands for phase shift keying, is a radio teletype type of mode where you actually type on a keyboard back and forth to your contact.
Words.
Whatever you type on the keyboard. It could be Morse code even, but it's keyboard to keyboard. There's APRS, which is the automatic packet reporting system, and it's normally used to be able to track stuff. Typically, if you have a transmitter that's able to send APRS, it will have GPS. So it can embed the GPS coordinates, possibly text, some weather information, things like that. And there are apps where you can track the APRS. We used it in the last two 10-mile runs at the Space Force and had APRS systems on the lead and tail vehicle. And last year, we actually had a runner that had an APRS transmitter, and we could track him along the course. So it gives you, it's a way to do real-time tracking data.
Where people or vehicles are, a lot of search teams, search and rescue, they can tell where all the search people are on a map by looking at the screen. They're all transmitting the signal, you can see where they're at and where they're searching, that kind of stuff.
In most cases, you need a computer to generate the modulation and demodulation. There are some transceivers that have a built-in computer that can do that. I have one called an S-bit, and it's got a Pi 4 in it that will do the modulation and demodulation and do all the different digital modes. Normally, you have to have a laptop or desktop hooked up to your radio to do it. Which of the following is a digital communications mode?
All of them.
All of them. Okay, we talked about packet radio, and we send messages as what we call a packet. And packets are usually a specific length. So a long message will be divided up into multiple data packets. And one of the things in the data packet is a sequence number. It's possible because of multipath and all sorts of things, or retransmission, that you could receive packets out of order. So you have to know the sequence number, how to put them back together for the message. So you could get packet 1, you could get packet 3, you could get packet 2. So on the receiving end, you have to know how to put it back 1, 2, 3. You can put an address for multiple destinations and send it, or you can set it up as a broadcast mode instead of going to a single address or destination. It can operate in store and forward. I think that would, as far as I know, would be satellites where you can send, if they support that mode, you can send a message or packets to the satellite. It stores that message until it gets to a point where it's over the receiving station, and then downlinks or downloads the message to the receiving station. So we call that store and forward. I guess that would kind of be VAR-AC, one of those modes where you can send a message and leave it there until the person it's assigned to comes. It's like a mailbox, and you can come back and read it at a later point. The packet message will consist of a header. Usually there's some sort of sync pattern. The header information, which is essentially destination address. It might also have source address. Be a checksum at the end of it. And the receiving station will look at that checksum. If it detects an error, it will send back what we call an ARQ, or an automatic repeat request, to tell the sending station to resend the packet. So that's its form of error correction. It doesn't actually do any correction. It says send it over. And it will do that multiple times. And that's one of the things that can be programmed, as how many times before it says, oh, sorry. Usually like 3, I think. But I'm not sure. I've really not done much packet, except for Ethernet, which is packet like this. So here, the typical frame, we got sync, we've got the headers, the actual data or message, followed by usually a checksum. It could be some more sophisticated Reed Solomon or something like that, as opposed to just a checksum. If you're not familiar with the checksum, all it is you add every bit in the message, and then you put that number there on the end. The receiver adds every bit and compares the two numbers. And if they don't agree, then you say, send it over.
Send it again. Try again.
So which of the following is included in packet radio transmission?
B, all the choices.
All right. I'm getting a lot of these, all the aboves. Okay. One of the special protocols we're talking about here, is we just talked about, is ARQ, where it's looking at the checksum and it's doesn't agree, then it says resend the packet. So what is an ARQ transmission system? Charlie. Okay. APRS, it uses packet radio or packets. Okay. So you're normally doing this in some mobile fashion, although my hotspot, which I think I have on a chart here coming up, sends out APRS even though it doesn't move. So, but you know where it is. It shows up on the map. because it has GPS. And normally most APRS transmitters are going to have a GPS source. In some cases, like if it's really a fixed station, you could just have pre-programmed GPS coordinates. Doesn't actually have to have a GPS satellite connection. You can add additional information. You can have text going along with it. We didn't do it, but in last year's race, the guy with the transmitter, while he was running, could have actually added text and sent it along. It's possible to have weather information. I'm not sure where the source is or how you set that up, but technically you can also send weather information. So it's really a real-time, what they call tactical information. And there's, like I said, apps where you can display the location as a map, and you can actually see, I forgot how, you know how fast it updates? Not very.
No, refresh rate. Yeah.
But you can actually see movement of vehicles if they're doing APRS. A lot of people, if they have radio in their car, if it's set up, if it's one that can generate APRS, you'll be able to see it move. Oh, yeah, there we go. This is one of those apps, and this is kind of a snapshot because some of this stuff is moving, so you can't really read it. This is local. There's my hotspot that doesn't move. Did you ever find out if your hotspot is doing, or did you set it up for APRS?
Not set it up for APRS. I don't keep it plugged in all the time either because my, I kept pleading with my wife to let me have one of the spare bedrooms. There's a man shack, you know, which is a combination of a man cave and ham shack. And she kept refusing, so I set up my radio on the coffee table and the family room. And then a couple of months later, she said, you know what, go ahead and take that back. So I'm in the process of converting the back bedroom from an unused
Okay.
space to, well, it was used for storage.
Well played.
This is a similar thing for Whisper, which is a similar form. It's not exactly real time, but and it's used by a lot by beacon stations, and they transmit Whisper format, which is weak signal propagation reporter. And you can do some apps like, and I don't know the name of this one, but you can see those and you pick a particular beacon, which is buried down here under all these. And it's showing all of the stations that are receiving that beacon signal. So you can kind of tell what the propagation path is, where it's the best. Which of the following is an application of APRS?
Alpha.
Real-time, tactical, with a map. Those are the couple key things that I always try to remember. What kind of data can be transmitted by APRS?
All are correct.
All the above. Okay, PSK 31. You done PSK 31?
There's a lot of PSK 31.
Oh, good. I haven't. It uses what we call phase shift keying as opposed to amplitude or modulation or frequency shift. And you change the phase of the tone that's being sent in discrete intervals, each one representing what we call a symbol. It has one of the narrowest bandwidths. It's called PSK 31 because it has 31 hertz. And I didn't make a mistake and put the K in there. Bandwidth. It's also a 31 baud data transmission, which is how many symbols per second is being sent. It uses what we call varicode, which if anybody's familiar with the ASCII encoding, where we represent all the alphabet and numbers in a digital representation with 7 bits or 8 if it's extended ASCII, and they're all the same length. In varicode, every character is a different length, can be a different length. So the ones that you use the most were set up on the chart, like the vowels, A, E, I, O, U, are 1 or 2 bits long. Things that, you know, like punctuation marks and things that hardly ever used, maybe 8 or 9 bits long. So that's why it's called varicode. So they tried to optimize the stuff that you use most often has the least amount of bits required to send it. And
Lowercase letters take less bits than uppercase letters of the same letter. So a lot of PSK 31 people just say everything in lowercase unless it's really necessary to have an uppercase.
right.
Just so the whole message goes much quicker. It's pretty fast. So,
And you type, right?
Yeah.
It's a keyboard to keyboard, I guess.
well, I can type well. I probably could type 40, 45 words per minute.
No, show off.
So type my whole life. But you can just the transmit rate, I start typing on there, they can keep up with me. That's how fast it's transmitting. So it's not slow. Or some other digital keyboard to keyboard are quite slow. You wait a long time for your message to send, but this is pretty quick.
So what does the abbreviation PSK mean?
Fish.
Bravo.
Yeah, they tried to trick you on this one with all these PSK things. Most of them don't make sense. Okay, another digital mode, and this is digital voice, which is different than the other ones, which are sending binary data or keyboard data. There's actually 3 popular ones. There's DMR, there's D-Star, and there's Fusion. DMR, I believe, was developed as a standard by the Japanese Amateur Radio Club, I think. And then Motorola was involved.
DMR was a Motorola thing,
Okay,
I think.
Yeah.
And D-Star is the
right.
Japanese.
And it's to the point where it's kind of proprietary for Fusion and D-Star. The standard's open, but the codec they use isn't. And that's why ICOM and Kenwood use D-Star. Yaesu uses Fusion, or they call it what's the other name for it?
Oh, I know.
No, it's a subplot,
Or FM. they
something
call
like
it.
that.
Yeah. Or Yaesu systems.
Right.
Yeah.
Most of the Chinese radios, the little more expensive ones, you don't get DMR and the $20 Bofang, but most of the DMR radios are Chinese.
Now you can get EMR Bofang for $90 though.
Okay.
And that's what led me to DMR was digital for under $100.
I actually bought a DMR right now. It's a TYT, so it's also Chinese.
Yeah, it's a 380 or 390.
390,
390.
yeah, which is pretty nice.
Yeah, it uses the same CPS that
I would have bought that Bofang, but they were out of those. Like with the next one, there was the next cheapest one.
I don't know anybody else that's got the Bofang,
They sold out everywhere. I couldn't find one.
Okay, I think the main reason they picked this one of the three is it's different in the fact that it uses time division multiplexing and will do 2 channels. So it has time slot 1 and time slot 2. So you can actually have 2 digital voice signals being sent. It alternates a sample from one and then a sample for the other, and just keeps going back and forth. D-Star and Fusion are single channel. So that's the biggest difference between them.
Star does have a voice channel and a data channel,
Right.
not 2 voice channels.
Yeah, and Jack and I actually tried it and talked on D-Star while sending a picture.
It's over the same radio transmission.
It wasn't fast. It took a while to send the picture.
And the resolution isn't great. It works.
Well,
Bandwidth is not like what you used to already.
Right.
I tried that 30 years ago. You'd have been like, oh my God, that was so fast.
and all of these allow interconnection to the internet. I mean, that's the basis for it. Your repeater normally would have a connection or a gateway to the internet to connect to other repeaters. So with any of these, you can talk to somebody else on the planet, anywhere potentially where there's another DMR, D-Star fusion repeater that you can access.
I taught myself how to do it, and I found out that you can actually listen without a license.
You can?
I don't have a license, so I can't
Oh, yeah.
complete the configuration.
It's always free to listen.
But it took me a while to learn how the talk groups work. And once you have the right talk groups configured, you can hear all day long. Except with, on a repeater, it probably work a lot better with a hotspot because a repeater has to be triggered. And I can't trigger it because I can't.
I was going to say, technically, you couldn't select a different talk group because you have to key the.
You can put multiple talk groups.
Yeah, but
I could put multiple talk groups to one channel.
to link to the repeater, you can't really do it without doing a link.
If somebody else links.
Well,
I can
okay,
hear.
okay, all right.
That's what happens. If somebody else links, and all of a sudden my video goes along, I'm like, it's working. I mean, but I bet you anything, I don't have one, but I'll see that. Yeah, I'm gonna buy one. If I buy a hotspot, I can probably just turn it on myself.
Right.
So that it's always on, and then I can hear it constantly.
Right. And you can kerchunk your hotspot because you're
I
talking
don't know what that
You-
is.
when you just key them on.
So I technically, but without
But you have to do that for digital modes in order to send a link or unlink command.
without being able to do a radio ID, the key button doesn't work. It just goes boop, and then the red light shows up that it's not transmitted.
Oh,
because he does.
Okay.
Unlike
Yeah, all right. Yeah,
Not, it does,
Right.
the transmit key does not work.
yeah, and it wouldn't work with D-Star because you have to be registered with D-Star.
Which is why I can't key up a repeater.
Right.
But if I wait there long enough.
You can
somebody else
listen, yeah.
keys it up.
Okay. Listen on Wednesday nights and Thursday nights.
What time?
Thursday, 7:30.
Wednesday is at 7:15, and I'll write the frequency down for you.
Okay, cool.
Okay,
Thanks.
and we talked about these interconnections can be divided up in what we call talk groups. So, and I guess anybody technically can create a talk group. And people can connect to that talk group, so it becomes a little like private group. I mean, other people can hear if they're connected to that talk group, but it doesn't get broadcast like normal stuff. It's pretty much confined to the talk group. They call those reflectors on D-Star. I think it might be reflector. I'm not sure what it is on Yesu. I've never used it, but it's the same kind of deal. You know, you can have these groups or whatever that you can connect to, and
Yeah, unless I found the list, once I found the list unrepeatable, then it all made sense. I was like, oh, there it is. So I have to go down the list, find the talk groups that people are using, and figure that into your radio. You can actually have multiple talk groups configured onto the same channel. So you can hear, you can only transmit on one if I had that radio ID, but I can listen to multiple.
okay. So, which of the following describes DMR?
Say alpha is correct, although I would like the answer better if it said two digital voice channels rather than two digital voice signals.
I didn't write it.
Yes, I know.
The VEX did.
Yeah.
Hmm?
Which Vex?
Oh, well, we hadn't got there yet. We will.
We'll get there.
Volunteer Examiner Coordinator. There's 14 in the US. And they have been delegated by the FCC sometime back, because in the old days, you have to actually had to go, so I understand, to an FCC office to take the exam.
You used to have to go to Tampa. I went to Tampa. You can go to Tampa or Miami years ago to take your radio license.
So now they've delegated it out to, usually it's a club, or a bigger group. Now ARL is one of the bigger VECs. The one we do down at Suntree is done by Laurel, which is the Laurel, Maryland Amateur Radio Club. And they do a lot of exams, probably all over the US, mostly east, I think. There's a Wi-Fi, is it 5Y or Wi, whatever. The one we do online is called CA-VEC, Central Alabama VEC, because it's up in Huntsville, and it's in that area. So we're doing online exams through that one. But they coordinate and are responsible for not only the exams, but the question pool, and which questions are on which exam and all that good stuff.
I think on the 14 volunteer examiner coordinator groups, I think they have representative from each one of them on a volunteer examiner council that actually comes up with the question pool. I think they're all represented. Development.
And that's, I believe that's called INVEC.
Yeah.
Because I actually got an email from them yesterday. So what is a talk group on a DMR repeater? Well, let's see. Yeah, you could say it's a group of operators sharing a common interest, but it's a little more than that. You have to actually be connected or select that talk group. And I would almost guarantee that the people on that talk group don't always have a common interest.
They argue.
Well, it's been known to happen. Okay. Another part of digital modes is there's a software suite, which is just a group of computer applications called WSJTX. It stands for Weak Signal Joe Taylor. X, I think, is the version. I'm not really sure what X means. Joe Taylor is a Nobel Prize winner. He developed a lot of these protocols that are used in the software for deep space communications with satellites and things out beyond the solar system, basically. So you're talking extremely weak signal. It even incorporates some stuff used by submarines for sonar, called the Costas array, which is one of the ways they use to kind of sync up these signals. It's very involved. It allows decoding of signals that are 20 plus dB below the noise level. I mean, in some cases, you can't even, if you look at a spectrum map, you can't even see the signal and it's able to decode it. You won't always make a connection. It consists of, I don't think I've even listed them all, but the suite has basically FT8, which is the most popular. FT4 is a slower 4-bit version, of FT8. I can't remember. I remember playing with JT9 once, but it's been a long time. There's MSK 144 as part of that, and that's used typically for meteor scatter on 2 meters. Whisper is one of the modes that's in there. Echo is one for doing what we call moon bounce, where you actually direct your signal to the moon and reflect off of it to a spot which could be halfway around, wherever. If both stations can see the moon, you can bounce the signal between the two. It's not easy.
I was gonna say, you have to have some pretty good precision, because this thing is.
Well, it's not that. I mean, your
200,000 miles
signal's
away.
going to be wide. It's the fact that there's 251 dB loss between going to the moon and back. Now, if you remember about dBs, you're getting back picowatts. I saw something the other day that claimed that you could do it with 150 watts on either 2 meters or 70 centimeters with like a 20 element Yagi. I'm not sure that's true, but first of all, it's hard to get 150 watts at 2 meters.
Yeah, well, and even harder at 70 centimeters.
Of all those modes, FT8 is the most popular one, at least at the moment. Is JS8 call one of these, or is that part of FLDG?
Different guide.
Different.
Yeah, adapted MTA in some way, or the details of it, but it's modified version of FT8.
Yeah.
They call it, what was it, JS8? What did you say? Not already. But anyway,
JS8 call.
yeah, JS8 call.
Yeah.
That's some guy with initials JS, a modification or something.
Which of the following operating activities is supported by digital mode software in the WSJTX software suite?
All are correct.
I was gonna say, I wanna say all.
Yep, they're all there. Yesterday morning, I forgot who it was talking about having done a lot of meteor scatter here recently and mentioning the fact that it's very short. You might get a few seconds or,
But you know when what's gonna happen.
well, you pretty much have to have a meteor shower.
No, it's coming.
You have to Right, I was gonna say, if the note's coming, you can't look, by the time you see it, it's already too late.
No, like
You
you have
have to
here,
all
you got
set up.
August, you got the first aid shower or something, or I don't know.
Yeah.
They use those opportunities to.
You have everything set up, right? Like you're already.
Yeah, you know,
Right.
Action, you're already like, okay, it's gonna happen, and you know, looking at your watch, okay, now.
Okay, what is FT8? It's got a Jared, because
Bravo.
we didn't really go through any details of FT8.
Bravo.
So,
It's one of the digital modes with very low signal to noise.
So, question is, what? For a technician class license, what bands do they have digital capability on?
You know, I was gonna look that up.
Well, I know, because there's a lot of questions related to.
Well, they've got, I mean, they're open from 2 meters and up.
Yeah.
Um,
But how common
Can you
is-
do it on 10 digital? You can do voice and CW, right?
Yeah, yeah, how common is FT8 on 10 meters with that? I don't know, 'cause I don't do
yeah,
FT8, but.
I've
there's gotta be- there's gotta be
I've looked
places
a
that would
few
have-
times and never see anything.
I mean, there's a lot of questions in the pool related to these digital modes, so you must be capable of that as a technician.
okay, so novice and tech have 28 to 28.3 for video data. So there is a space there for it
On 10 meters.
on 10 meters.
Okay.
Whether or not it's used, I don't know.
Yeah. Well, at least 10 meters is quiet.
Yeah, and 10 meters is a huge band too, so.
I guess you could
I
just not,
suspect that's why. Yeah,
Well, at the right time of day,
3 to 5, 28.3 to 28.5, they've got voice.
but you can do it on 6 meters, 2 meters, just how prevalent is FT8 on those VHF bands, though? I don't know, I'm not, I mean, to me, it's mostly an HF
yeah.
thing, so basically it would be 10
Well, yeah.
meters.
Technically, you can do it on 2 meters,
Yeah.
but
Yeah.
uh,
Not many people. But
I haven't tried. I think I'm gonna try it sometime.
So
Okay.
could you, I'm gonna draw more detail than they need to know here, but on FTA, can you do that with that phone?
Uh,
Is it normally upper sideband?
yeah, it's upper sideband, and that's one of the exceptions because even if you do it on 80 or 160 or 40, it's still upper sideband.
Scheme 31, same thing, it's always upper sideband,
Um,
but anyway.
yeah, I don't
You
know
can do
because
sideband on 2 meters.
all you're doing is you're sending
Not sure.
an FM tone on FT8. I mean, you're sending, around, let's say it's 1500 hertz from your carrier, and you got a 50 hertz band there at the top of that where it's, every symbol is like 5.2 hertz. So in that 50 hertz, you got 8 symbols.
You have to be in the software suite, so you have to tell us somewhere that.
Yeah.
So we know how to encode and decode that. Yeah.
Okay.
According on 10 meters, but. Like
Yeah.
FTA does technician license, if you want to be getting digital.
Well,
mode.
yeah, I've done it on 10. Of course, I'm allowed.
Yeah, yeah.
Not much activity.
Well, it's like PSK 31, but typically it's 20 heavily and then 15, 40.
Okay, they keep having this mesh networking in the question pool, claiming it's a popular amateur radio activity, but I don't know anybody in this area that does it.
Oh, yeah.
And basically, you take a commercial Wi-Fi router and modify it with different firmware, and use it to create your own little, what we call mesh network, where they're all interconnected. So you have multiple paths and you can pass information between the Wi-Fi routers. And they also, because you're operating at under license, you can up the power. Whereas if you go buy a Netgear off the shelf, it's what? 10 milliwatts or something.
That's interesting, because I do this, right, my day job,
Okay,
and everything that I've learned is I'm not allowed to modify those things.
because
It's
you're
FCC regulated, and I do it globally. So not only have to worry about FCC regulations, but in Europe I have to worry about Etsy, and in China they have their own, and Japan has their own,
Yeah.
India has their own. And there's about 15 global regulatory domains like FCC. I have to worry about all of those in each individual country. And they're not, you can't take a piece of equipment from this country and take it to
Oh.
another country, because that's illegal.
all right.
So I'm reading this sentence, it says I can modify it all of a sudden. That's blows my mind. Since when are we allowed to modify?
To use it as on the amateur band, if you're licensed, you can do it.
Doesn't say
and you
none
can
of
up
that
the
in
power.
manuals of that commercial equipment. Doesn't say unless you're an amateur, you can make changes today. You gotta bring that up at work.
Because remember the 2.4 gigahertz and the 5.8 are shared. Okay, with the
Wi-Fi.
with Wi-Fi, which is open.
Well, it's open, but it's not wide open.
Yeah, but we can use it at higher power.
Which is dangerous.
Well, not if you know what you're doing. Anyway, like I said, it's a question.
2.4 is your microwave.
I don't know who does it.
When you cook things in it, it's 2.4.
Okay. There's some examples of this broadband hamnet, which apparently uses it, and the amateur radio emergency data network, which are both mesh networks. I don't know what the range is, but if you have enough stations, I mean, you could do it over the whole country if you had, thousands of these stations around. Which of the following best describes an amateur radio mesh network?
Gonna scream it out first, but again, I read the rest of it, but just in case.
Yes. That's a good idea. Always read them first. Okay. So we learned that packet, Wi-Fi, FT8 are all examples of digital communication modes. Packet contains actually a header, a checksum, and possibly an automatic repeat request if there's errors. So it sends a request for retransmission. APRS is basically providing real-time tactical communications with mapping. So you can actually follow the system when it moves. Can have GPS and usually has GPS, may have data or text and weather. And PSK31 is phase shift keying, where each the phase of each tone is different. That's how you determine whether it's a 1 or a 0 is what the phase is. DMR, called digital mobile radio, is it's actually more than a technique, but it's the only one that does the time multiplexing of two digital voice signals on a single channel. Talk groups are a way for a group of users to share a channel without having others. So it's kind of like setting up a private channel. Although anybody can join it, it's not exclusive. WSJTX is a software suite, supports moon bounce, propagation beacons, which is Whisper, meteor scatter, FT8, which is most popular. Mesh networks, amateur radio can set up a mesh network by modifying commercial Wi-Fi equipment. I think you have to do more than just the firmware. You got to increase the power. Because I know my Wi-Fi router
Max out at 100 milliwatts.
doesn't go much out of the neighborhood.
That's when it's out at 100 milliwatts.